Here. Today I will be showing the Rlay prototype UI. First, we see how to construct a machine and human understandable proposition and how to submit that to the blockchain we are working with. And second, we see how to express our beliefs about conflicting propositions in a network with the help of Rlay token. So what you're seeing right now is only the UI. But in the background, we have a blockchain with the capabilities of the Ethereum EVM running. And on that blockchain, our smart contracts that make up the Rlay protocol have been deployed and are ready for us to use. Let's start all the way at the bottom. What we have down here is what we call the ontology. Completely at the bottom, we have the most atomic parts of it, like annotation properties and annotations. And going further up, we have more complex concepts like classes and propositions that are made up from the atomic parts more at the bottom. All these different kinds of entities come from established standards like RDF and OWL. They're currently being used for the semantic web, and they already help website owners expose data in a machine understandable way. We took those standards and adopted them into a format that has the properties we want in decentralized protocols and applications, such as immutability and content addressability. What content addressability means is that we can take a blob of data, as seen here on the right, create a cryptographic hash from that, as seen here on the left, and going forward, we only need that cryptographic hash whenever we want to refer to the data on the right-hand side. One of the most important aspects of the format is that it allows us to express different concepts relate to each other. One example of that are the classes we have here. For example, the university class is a subclass of this right here, which is defined up here, which is the organization class. What that essentially means is that every university is also an organization. In combination with the content addressability, this allows us to build up sophisticated concepts which we can refer to with a single short hash. Now after this short introduction, we will create a new proposition that expresses the thought of Stanford is a university. For that, we first create label annotation all the way. For that, we first select the annotation property for a label, and we'll enter the value Stanford for it. So now we've created the annotation locally in our browser. But for it to be really useful, we have to submit it to the blockchain, which we can do with this button on the left, which creates a new blockchain transaction. Here we get a short confirmation pop-up, which shows us the detail of the transaction. Normally, this would be provided by a wallet like MetaMask or Ledger. We now confirm the transaction. Now we have the first part, the Stanford part, but we also need the university part, which we luckily already have defined up here. Now that we have both parts, we want to create a full proposition. For that, we first have to specify the subject we want to say something about, in this case, Stanford. And as we want to make an association statement with it, we make a class assertion, namely the university. This together means express the thought of Stanford as a university. We submit that to the blockchain, and we'll create a second proposition that is the opposing view of Stanford is not a university, which we can do by selecting a negative class assertion down here. Up until now, we've basically just been shouting stuff out into the world. Stanford is a university, Stanford is not a university, but how do we know what's true and what's false? That's where the Rlay protocol and the Rlay token come into play. By creating two contradicting propositions earlier, we created what we would call a proposition pool. For each proposition pool, there are potentially many different values, and our demo only two is a university and is not a university. And for each proposition pool, we also have one aggregated outcome, which reflects the consensus of the network regarding a current proposition. Right now, as we can see, there is no way to put onto this proposition pool that reflects whether Stanford is a university or not. And we will change that right now, as we know that Stanford is indeed a university. And as the first suppliers in the pool, we can expect a high reward when that proposition ultimately turns out to be true. To do that, we enter our desired amount of Rlay token. We want to put at rate as weight onto that transaction and submit the transaction to be included in the next block. Of course, we can also participate into existing proposition pools, like this one up here that says that currently says that Wikipedia is a university, which we know not to be true. We will fix that by adding some weight onto the opposing statement of Wikipedia is not a university, by adding some tokens to it and submitting that proposition again. We can see as our proposition has been accepted into the next block, now the aggregated outcome is what we assume to be correct. Wikipedia is not a university. This concludes our short overview of the Rlay prototype UI. Please keep in mind that this is the most manual way to submit propositions to the network right now, and that algorithmic suppliers can of course directly interface with the protocol to submit their propositions in a more automated fashion. Thanks for your attention. I hope you enjoyed it.